Okay, so hopefully the rest of this will go a lot faster because one, I'm only going to be focusing on the parent function absolute value, and two, everything that we just did about outside parameter changes are going to be now opposite with inside parameter changes. Okay, so we've got outside parameter changes. We talked about outside parameter changes. We know that they affect the graph vertically. Okay, so absolute value, everything that we're doing in this section is about absolute value. But the good news is that everything that you learn about these parameter changes and the absolute value function will transfer later to other functions. Okay, so absolute value change. Predict the transformation for, okay, so the first thing you should notice is that this minus 3 is an inside parameter change. Okay, inside parameter change. If outside affects the graph vertically, then what's your prediction for inside changes? Think for a second about what the inside changes would be. Okay, hopefully you thought maybe it's a horizontal change. And you're absolutely right. So inside parameter changes cause horizontal changes to the graph. Horizontal graph changes. Okay? Remember, those graph changes are called transformations. Okay? Graph changes. Those are called transformations. Okay? Those graph changes are called transformations. So, inside parameter changes cause horizontal transformations. Because it's a plus or a minus, okay? Plus and minus cause, you remember what they cause? Shifts or translations. Okay, so when I see this minus 3 and it's inside the absolute value bars with the x, I think inside parameter change, it's plus or minus, so that means it's going to cause a shift, or I could call it a translation. But here's where it gets really weird. Okay, you might have predicted that this negative 3 would make it go left 3. And I totally get why you would say that, because minus 3 on the outside made it go down. So why wouldn't minus 3 on the inside make it go left? Well, let's see if our prediction is right. If we go over to Desmos real quick and we type in the absolute value of x and we put minus 3 in there with it, look what it did. It did not make it go left. It made it go to the right. That's because they're asking you what x value right here would you have to put in here in order for this absolute value to be 0. And we would need a positive 3 in order to make 3 minus 3 be 0. So we have to move to the right to get the correct x value to make that be 0. I know that's confusing. The easiest thing to remember is that here's what I remember. I think, okay, so outside changes behave the way they're supposed to. So that's why they get to be on the outside. Inside changes do not behave the way they're supposed to, and that's why they're on the inside, so we can keep an eye on them. I know it's kind of silly, but inside changes do behave opposite of what you think. So if we see minus 3 right there, we've got to remember to go over, let me get my blue, go over 1, 2, 3. Minus 3 caused it to go over 3 units. Okay, so here's how I remember. I do this little thing right here. Inside changes are horizontal, and those are you can kind of see, maybe that's that I, if you turn it over sideways, it looks like an H. I don't know. Inside changes are horizontal. Horizontal means move this way, right? Left and right. But this direction is where I go if I'm a plus. This is the direction I go if I'm a minus. Outside changes are vertical. And vertical means up and down. And if I see a plus, I'm going to move up. And if I see a minus, I'm going to do down. Inside horizontal, outside vertical. IHOV. Okay. Remember, make something up to remember that. And then when you draw your arrows, plus and minus, this might be confusing because this was just an extra little thing that got put right there somewhere. Okay, now my plus sign got erased. Okay, so this is what I use to remember all of this. Okay, so this one right here, predict, okay? If you think it behaves like the vertical ones, again, you're going to be wrong. Remember, the negative would reflect it down, and the 2 would cause it to stretch. So that's what we're predicting, opposite things. So instead of going down, it's going to flip left and right. And instead of being stretched by 2, it's going to be compressed by 2. So let's go look at Desmos and see what happens. Whoops, I picked the wrong one. Go look at Desmos. So the other one that they wanted us, let's put, leave the absolute value of x right there, okay? Let me pull it down. And then here, I'm going to type in the negative. Let's do one at a time. Oops. I need the absolute value bars around that. Okay, so the negative x. Now, some of you may be saying, wait a minute, I can't see that one. Well, let me turn that one off. And there's the blue one. Let me turn the blue one off. There's the red one. What is that telling you? That the red and the blue one are identical. So maybe the absolute value one's not the best one to show you. Let's do this one. If I type in the parent function x cubed, okay, now put parentheses. Where's my parentheses? And type in negative x cubed. Okay, and now you can see what happened. See, what was on the left, on the right side over here is now reflected across the y-axis. And what was on the left side has been reflected. So what happened, we got a reflection across the y-axis, a left and right reflection, or a horizontal reflection. Okay? It's easier to see. You couldn't see it on that absolute value one because the absolute value one is the same. It reflects onto itself. The absolute value of negative x. You end up with kind of a purple graph because you've got red, there's the red one, there's the blue one being graphed right on top. And that's why you can't tell the difference, because this one reflected over here, this one reflected over there. Okay, so again, let's do the 2. I want to do the 2 separately so that you can see. See, on this time, the 2 behaved opposite. We thought it was going to be that's a terrible example. 2 on the inside did not cause, oh Lord, that's just so confusing. Okay, it caused a horizontal. It didn't, what happened is it didn't change the y values, it changed the x values, and we have to take half of the x value of each one of these. Don't worry about that one. We'll talk about that one when we get face-to-face and in class. Good grief, I'm out of time again. Okay, so what transformations did your graph show? We'll talk about that at the next recording.